In the second step of SEDA, we redesigned the system around business domains. Boundaries were redefined, responsibilities were realigned, and teams were structured to support how value flows through the system. But once the structure changes, something important happens. The system does not simply stabilize, it begins to behave differently. This is because sociotechnical systems are not static. When we change one part of the system, we influence how other parts respond. New interactions appear, existing patterns shift, and sometimes new problems emerge where none existed before. This is what we refer to as emergent behavior. Behavior that is not explicitly designed but arises from the interaction of multiple components in the system. For example, we reduce dependencies between teams to improve workflow. That may increase autonomy, but it may also reduce coordination in areas where alignment is still needed. Or we simplify ownership boundaries. That may reduce hands-off, but it may also concentrate responsibilities in a way that creates new bottlenecks. These effects are natural consequences of working in complex ecosystems. So the question is not how do we eliminate unexpected behaviors. The question is how do we observe and manage such behaviors in a system. This is where feedback loops become essential. Feedback loops describe how actions in the system produce effects and how those effects influence future behavior. Some loops reinforce change, others stabilize the system, and some create unintended consequences that grow over time. For example, if reducing dependencies improves delivery speed, teams gain confidence, which encourages further decentralization. That is reinforcing loop. On the other hand, if increased autonomy leads to inconsistent decisions, additional coordination mechanisms may be introduced, which shows the system down again. That is balancing loop. In practice, these loops are often not visible at first. They develop over time, and if they are not observed, they can gradually reshape the software ecosystem in unintended ways. This is why in SEDA, redesign is not considered completely after a structural change. It must be followed by systemic observation. This observation is based on signals, not only technical metrics, but also operational and organizational signals. For example, changes in delivery patterns, shift in coordinations, effort, recurring delays across boundaries, or increasing variability in outcomes. These signals help reveal how the system is responding to change. Over time, patterns begin to appear, and these patterns can be traced back to underlying feedback loops. At this point, the role of architect or transformation lead changes. It is no longer about defining a structure. It is about regulating system behavior. Some loops need to be reinforced, others need to be balanced. And in some cases, structural adjustments are needed again to correct unwanted dynamics. This creates a continuous interaction between structure, software, architecture, system behavior, and feedback. And this interaction is what allows the system to evolve in a controlled way. Without this step, transformation becomes unstable. Changes are introduced, but their effects are not fully understood, and over time, the system may drift back to the previous patterns or more into new forms of instability. So step 3 is not an optional refinement, it is what allows transformation to remain grounded in reality. And this is lead to final steps, how to sustain the evolution over time without failing back to one-time transformation thinking.